Hi, everyone. I'm Elango, and this is Tim. Our talk is entitled Learning Clojure Through Logo. And just as a disclaimer, this talk presents our personal views, but they're not necessarily reflective of those of our employers. So this talk will be about three main ideas. The first is, why is Logo a compelling learning environment? The second is, how does Logo relate to Clojure? And the third is, how can Clojure expand its potential audience in ways that might be surprising? So at its most basic, Logo is a programming language to control an object that we call a turtle. And the turtle is represented by a triangle, although sometimes it might be pictured as a turtle itself. You send movements to the turtle, like forward, back, left, right, telling it where to go. And the turtle carries a pen, and when the pen is down and the turtle moves, it draws a line. Thanks. So you can issue commands like this. So right 30, and we're telling the turtle to turn right by 30 degrees. Forward 50, so we're telling the turtle to move forward by 50 units. Left 60, telling the turtle to turn left or counterclockwise 60 degrees. Forward 50, back 100. And so now we've drawn a little lambda. So the syntax for Logo looks something like this. So this is a function that says draw a stop sign, so we're drawing a stop sign. Now it turns out that Logo is actually a Lisp. So you can see that there's a lot of similarity. The function's always in first position, there's a very simple syntax that's regular, and there's nested expressions. So if we go back to the Logo syntax, we can look at it and think of it as Lisp without the parentheses. Now, as it turns out, what's old is new. So Logo is a few decades old, but it's very popular right now in teaching kids, but in a graphical form. So this is Scratch. It's a desktop application where you drag blocks of code, and you snap them together, and you move a sprite, which is, in this case is a cat. But instead of a turtle, it's a cat, but it's the same concept. And as applications move towards the web, then they typically use a library called Blockly, which is a JavaScript library created at Google for creating these kinds of graphical coding environments. So you'll see Blockly used in code.org, and you might even see physical toys that have a connected app with a coding environment, and those connected apps will also use Blockly. But here you can see the Logo origin, because we're moving a character using spatial commands. As Lispers, we can see these code blocks and think of them as Lisp forms, everything between two parentheses. And if you use pair edit mode or some other structural editing environment, then the act of snapping these blocks together and nesting blocks inside other blocks is a lot like some of the functionality that we already use. So there's an irony in all this, which is that here we are today, we're using Lisp as an easy, effective way to teach kids how to program. And then when they grow up, they go off into the world of curly braces and semicolons, perhaps, and that's how they learn to program. And here we are, we're at a Clojure conference. So we've come back to Lisp because there's this unrivaled power of macros, and there's this simplicity. So all of this begs the question, if the same thing is very good for beginners, and it's also very good for advanced users, then why do we avoid it in between? So I want to tell you a story about how I learned programming. So the very first language I used was BASIC, and that's because I was playing video games in elementary school on the Commodore 64. And I knew that the Commodore 64 had BASIC in it, it had a BASIC compiler. So I thought it would be really great to do more interesting things. But as I quickly found out, it was really hard to do anything of interest. And so then I thought, this is BASIC, but I can't do anything. It must be me. I don't know how to do this. And I gave up on programming. And for whatever reason, the next year, I was 11 years old in middle school, and there was a class on Logo that I decided to take. And it was just so much fun. I was drawing things that I wanted to draw, and then they taught us how to do functions so that we could do even more interesting things, and even recursion. And it was just so exhilarating that it renewed my interest in programming. So now I want to tell you about how I learned Clojure. So this was 6 years ago in 2011. And at that time, it wasn't clear to me what the good resources were to learn and in what order. I mean, there's tutorials and websites and books. But it wasn't clear what a good progression was. But once I did get started, it was a little bit odd for me to get started with the environment because everything was pretty command line based at that time. But I went through the materials, learning about seeks and data structures and core functions. And it felt a little bit abstract with all the examples, but that was okay. But I think the one thing that I likened the learning experience to was how I learned command line utilities in Unix. You have a bunch of small, simple, well-crafted tools working on a common abstraction. So it could be command line tools on streams or really well-defined functions operating on the seek abstraction. But when you're trying to perform a particular task, you think maybe there's this function that's perfect for what I'm trying to do, but you won't know it until you know it. So I felt like the learning experience was sometimes making some progress and then kind of bashing my head against the wall, not understanding something, and then overcoming that obstacle and repeating. So I thought there has to be a better way. I mean, this can't be as good as it gets. So after knowing that Logo is a Lisp, I thought, why not implement that in Clojure? So that led me to creating the clojure-turtle library. And so as the name suggests, one of the first objectives was to implement Logo in Clojure. But another objective was to use Logo somehow to make learning Clojure easier. So to give you an example of what that looks like, let's start off by drawing one of the simplest shapes, a square. So we'll go forward 30. We'll make a right turn, so right 90. And then we'll go forward again, right, forward, right, forward, right. And we have our square. OK, so that was a little repetitive, so let's simplify that. So here we'll say repeat 4 times, do forward 30, right 90. And we have our square again. OK, so now let's create an octagon, or a stop sign shape. It takes 2 turns to make a full 90 degrees, so each turn will be 45, and it has 8 sides. So here we'll repeat 8, do forward 30, right 45. And we have our octagon. OK, now let's give that a name. So we'll say defn octagon, repeat 8, forward 30, right 90. And if we call our octagon, we get it back. So now we can say octagon. OK, so we know how to repeat. We know how to turn. So let's see what happens if we repeat calling our octagon and turning a little bit after each turn. So we'll repeat 12 times, doing our octagon, and then turning right 30. And we get this spirograph-looking pattern. OK, so let's change the color and do that again. OK, so let's go back and see what we can do when we start to mix in a little bit more Clojure gradually. So we'll go back to our simple octagon. And if we know the length of an octagon, then we can start to draw things around the octagon. So don't worry about the code to define the size of an octagon. But what we'll do now is we'll pick the pen up. We'll move forward by the size of an octagon. We'll put the pen down. And we'll draw an octagon. So now we have one on top of another. And we'll do it again. Pen up, forward, pen down, octagon. OK, so now let's use range and map to create a column of octagons. So first what we'll do is we'll define a function that draws an octagon at a particular height or y coordinate. Then we'll define the heights or the y coordinates that we want to draw these at. And now we have a function that draws the octagon at a particular y coordinate. We have our y coordinates, and we just need to map the function onto y coordinates, and we get our full column. Okay, so now let's cover the whole canvas. Instead of worrying about pen up and pen down, we'll use set xy to teleport the turtle. So first what we'll do is we'll use the for function to create the collection of xy coordinates we want to draw our octagons at. Next, we'll generalize our octagon drawing function to take an xy coordinate. And to make things interesting, we'll make the color random. And now that we have our new function, and we have our xy coordinates, all we need to do is map them. So now we've tiled the plane, and we have random colors, so if we do it again, the colors will start to change. So why is Logo interesting? Logo is an environment that's simple, interactive, and visual. And all of those aspects are important for a beginning learning environment. And Logo is all three of those. Logo is also often taught in an exploration-based environment. So oftentimes in a classroom setting, you'll see a picture shown up on the board and say, here's what we're trying to draw. Can you draw it? And there might be hints, but you're not taught to do things. And what that does is it gives the learner a sense, it requires the learner to interact with the environment and manipulate the environment. So it gives a sense of self-discovery and excitement, and you start to wonder, what else can I do? But ultimately, it gives a sense of empowerment, because you're in control of what you learn and how you learn it. And Logo was envisioned as more than just a turtle on a 2D screen. The turtle was also thought to be, envisioned to be manifest as an actual robot. Because interactivity means more than just one sense. It's more than just our sight seeing what's output. There's also the sense of sound and the sense of touch. And interactivity also means more than just output. It's more than just giving commands and watching the output come out. If we have a physical robot, it might be able to sense a barrier and respond to it and turn around. By having a physical object, it makes things real for us. It's tangible, it's relatable, and it's connected to our reality. It's not this abstract concept on a screen. But here, too, what's old is new. So there are lots of toys coming out where they're either robots or cars, and they have a connected app component where you have graphical blocks to write your code and control those toys. But you can see that graphical environment is very much based on Blockly, and those robots are very much the same old turtle. And there's Microbit, which is a breadboard that you can use connected to an app, and you can code up different things that you build around it. And here's an example of an electric guitar. So all of these benefits of Logo are not a fluke. It's not a happy coincidence, but it's actually by design. So Logo was created by Seymour Papert, and he was a researcher in education and computer science. And so for him, his goals with Logo, first and foremost, were interactivity and exploration. And that's based on his theory of knowledge, which is that when we have new information, we absorb that into systems that in our mind and those that to make sense of that new information, and that is knowledge. But he believed that he went further, and he said that knowledge, for it to make sense, it has to relate to the existing knowledge. So in other words, there's new things out there, and if we take that new information, we can only really absorb it if we can relate it to what we already know. So he believed that knowledge acquisition happens best when we can make those relationships. But he also believed that knowledge acquisition happens best when we're put in control of our own learning. So he didn't just design Logo as a means to teach programming. He also designed it as an exemplary way to demonstrate his theories. So if you're interested in any of these topics, or even if you're interested in teaching Clojure, I highly recommend reading his book, Mindstorms, which talks about all of his theories at depth. So we'd like to just stress that we're not the first people to implement logo and clojure. There's certainly prior art. Narella Akaya had a blog post talking about this. There are other projects on GitHub that do this. We're certainly not the first to implement logo in the browser. There's JavaScript implementations, and there are other learning environments that, even if they're not, they're transitioning to the web. But we have a different focus with what we're doing. We believe that there are two things we're trying to do. We're trying to blur the lines between logo and clojure, and we're also trying to blur the lines between what's considered turtle and what's considered programming.
So I have a bold claim to make, and that is that I believe Clojure is the best first programming language for everyone. I have some stuff to show you that I hope will convince you as well, but I didn't believe this last year. So last year, my friend Nathan came up to me, and he said to me, "I'm ready to give Clojure a try. I've even installed Emacs," and I was like, "That's awesome. Clojure is so cool. First, we need to do some setup. So just go ahead and install Java, get lineage in. I want you to run this command to create a project, please, and add these dependencies into your project file. Start a REPL. Okay, press Control-K, meta J." And he was like, "What is all this? I just want to learn Clojure. I don't care about any of that stuff." He didn't like it. And Nathan's one of the best coders I know. Like, he's really experienced, but there's a barrier here. And it's easy for us to forget about this or dismiss it because we're familiar with our tools. They're just mundane to us. But for a complete beginner, it's the difference between can and cannot. So it's a big deal for people. But the good news is that all that kind of changed thanks to self-hosted ClojureScript. All you need to code Clojure is a web browser, and that's a huge deal. So I'd been talking with Elango about his ideas about teaching Clojure through Logo, and we thought, well, what if we could marry a ClojureScript REPL with his turtle library? And the result was PowerTurtle. This is our website URL down the bottom here, and I'll just quickly show you what it looks like. Oh, thank you. Up the top here, we have some lessons which just really gently introduce you to what you're able to do in this world, which, as you've seen, is forward, right, all those sorts of things. And just encourages you to use them in different contexts and start building up how to draw patterns and that sort of thing. Pretty soon we get on to defining a function. It's just a very basic function that combines your existing commands into a new command. And then again, it's just more practice with that in different contexts and so forth. There are other more advanced lessons, which we'll come back to in a moment. But what I really want to show you now is just what's capable with PowerTurtle. So don't worry too much about the code in these examples. It's really just showing you what's possible if you push it to its limits. So we all know that Logo is great for doing things like geometric shapes, and there's a whole lot of things you can do with that. What I think is a neat little addition is you can actually put your steps into a button. Hopefully you saw that I just added a button to my UI here by just calling this function, and now I've got my own little thing I can just click. And I feel this is nice because you can build up your own drawing program using Logo. And we have multiple canvases, so you don't just have to stick with Logo. You can work in this raster world. And a raster is just essentially it's a monitor. You can set pixels on. You can draw horizontal lines, vertical lines. And I think it's a nice way to teach sequences. You can come up with some interesting patterns like the American flag, and you can imagine how there's a pattern behind that. If you really want to push it to the limits, you can create Conway's Game of Life in this little raster world. I'll quickly show you the Quill canvas, which Quill is a more fully featured drawing system. It has ellipses and all those primitives, but you can also do animation. It's very powerful, so I won't go into it here. This chart canvas is here because very naturally when we're teaching Clojure, we fall back to math, and so I think it's nice to be able to do things like plot a range of numbers or plot a function, so that there is a visual representation of the math that's going on as well. And of course, you can plot data sets as well. And please note, like, we're just calling chart here with some numbers. Like, it's really basic. You don't need to know about charting. My favorite is the HTML canvas because you can edit the page itself. I think that's kind of fun. You can do, obviously, headings. You can do input boxes. You can do lists. You can do anything HTML includes, which means you can do SVG. You can do buttons. So you can make these little widgets and games or whatever. So, you know, it's just up to your imagination. If you really want to, you can embed other canvases in your canvas, which is kind of fun. So the key point I want to make here is that you can do all of this without any setup. Like, you don't need to know anything about the JVM. You don't need to know about dependencies. You don't need an editor. You don't need to know about namespaces. You don't need to know about referring symbols. You're just using the commands. So I think this is great for people like Nathan because he can get to use Clojure without investing his time in the tools. And obviously, I think it's great for beginners who just can't deal with the tools. So I promised to show you the lessons, and let's have a quick look at those. I just want to show you that they're just slides at the top here, and they just all have a different theme. Some use different canvases, but there's some stuff here, and what we're aiming for is we want a progression, right? We want people to start out learning about function calls, just getting comfortable with how to do that, how to combine functions into new functions, and then move on to repeating functions, creating sequences, using those sequences, modifying those sequences, and always building cool stuff, like in the canvases. And like what we really want is for them to continually move on to more advanced things, so they slowly transcend Logo into interesting things, all in Clojure.
So one thing that we've noticed in our experience is that when learners get to functions, and especially if higher order functions are included, it becomes an inflection point in their learning curve, and things start to become harder, and some people have difficulty. So maybe we're so excited about functional programming, we start talking about things like functions or values. But what we've seen is that problems occur when we start to explain things before learners have had a chance to internalize those concepts. So at least from our experience, we believe that what works best is if you can show a concept first and encourage practice before you attempt to explain. So for example, if we just show them, here's repeat, and inside repeat, you give it a block of commands, and you show it to them, they'll just get it. We don't talk about higher order functions or functions. And this example from Blockly Games shows just that. So here we have a repeat block, and inside it, we have the commands that are being executed, and it's just intuitive. You don't even need to say what's going on for them to get it. But the inverse can be true too. If we try to explain things too early, it can really disrupt the flow of learning. So this progression becomes very important. At least in my experience, I've seen books and other materials where macros get introduced as early as midway through instead of left as an advanced topic towards the end. And my belief is that you don't have to write a macro, you don't have to learn how to write a macro in order to use it and appreciate it. And I've seen other examples where the list function or the vector function or the cons function get taught perhaps early on. But in my experience, I don't use those as often as I use other functions, except for perhaps when I'm writing a custom macro, or I'm trying to transpose nested data, or I'm perhaps creating my own custom lazy seek. So if Pappert were here and he saw that we were trying to teach functional programming, through Logo, he would say, this is great. It's visual, it's interactive, and this is all necessary, but it's not sufficient. Like, there's more that you need to do. He'd say, all this new information that you're teaching, you have to make sure that when you teach it, it has to relate to what the learners already know. So let's look at Clojure and Logo. So Logo is a simple environment with a small set of primitives. And that really allows learners to internalize it easily. So likewise, we think that we can teach Clojure by starting with a small set of primitives. So when we look at Clojure versus Logo, we see that it's easy to learn everything in Logo because there's not that much to learn. And it's pretty easy to teach. It's hard to do it wrong. But with Clojure, it has a larger core. So the ordering of those concepts matters a lot more.
So perhaps you have a lesson in mind that you'd like to teach yourself. And the good news is that lessons are just text files. They're markdown, they're really easy to edit. And we realize that we want our lessons to cater to most beginners, but beginners come from different backgrounds. They might be from school, they might be from university, might be from other fields. And maybe they speak French and they need a translation. So it was really important for us that you can create your own lessons really easily. And if you want to just deliver your lesson, you can actually just append your markdown file URL if you're hosting it somewhere, and it will load up in PowerTurtle, and you can start using it. We would really love it if you would send us the markdown, and then we can put it in the lesson index, and everyone can benefit from it. Here's a piece of feedback I received about the existing lessons. It was quite astounding how Noah went off on his own tangent to draw his own patterns about halfway through the lesson. And this is exactly what I'd hoped for. Lessons are a guide, but you can do whatever you want. And the emphasis here is on self-discovery. I think lessons are most interesting when they kind of give us a challenge. Can you draw this thing? And then they maybe provide a concept to get you there. So getting started with PowerTurtle is easy, but there's an even bigger barrier for most people who want to learn Clojure, which is they have to learn a foreign language first. So I'm currently learning Korean, and I can tell you, wow, it's like really tough to learn a language. It's a big deal. It takes a lot of work. And my friend Alex is from Korea, and I asked him, how did you learn programming? And he said, well, first I learned English, then I went to an Australian university, and now I work at Microsoft. I mean, sounds so easy, right? But we all know there's a decade of dedication that is involved in that. But only 5% of the world speaks English, and 20% if you include bilinguals. So most people, when they want to learn programming, their getting started experience is, awesome, programming's really cool, but go learn English first. I happen to know that Elango had translated Clojure to Tamil. And so I thought, well, I wonder if we can do that for PowerTurtle, and of course we can. So here's just a small example showing you a Korean forward, a German right, a Tamil forward, a French right, and a Chinese forward. And of course you can use all of Clojure's functions like map and range in this example. You'd probably want to stick to one language. This is very polyglot programming right here. But yeah, it all just works. So you can code Clojure in your language. Parlez vous clojure? I'm pretty sure Clojure is a French word, right? So it's kind of weird, but Elango and I get this common response to programming in another language, which is they're going to have to learn English anyway, so why bother? And there's a point I want to make here, which is that translations are just great. I mean, they're really useful. You know geometry, it was translated from Greek. You know astronomy, it was translated from Latin. Einstein, German, Marie Curie did all the work in French. They're just plain useful. Translations are great, and they're super easy to do in Clojure, so just why not do them? This is Elango's library. It works great with Clojure. It relies on macros that write macros, which doesn't work in ClojureScript, so we made something that works in both. And we call it Clojure by another name, or CBAN for short. It consists of a plugin that you can use to wrap your own libraries or other people's libraries, and CBAN itself is a collection of translations of Clojure core to other spoken languages. The translations themselves are just text files, so they're very easy to work with. So let's get everyone in the world learning Clojure. This will be great, right? What could go wrong? Probably nothing. This did go wrong. This didn't work out so well for me. I got this email, "Dear Tim, error, cannot read property call of undefined. Not sure what I'm doing. Love, Mom." So there's still some friction here we need to smooth out, and I'd really like to replace this with something more helpful in the future. So perhaps you're interested in building something like PowerTurtle yourself, and so I want to give you some pointers on how to do that. If you have a blog or a website, you should definitely use clips. All you have to do is include a script in your page, and it will find any code blocks that you already have in your page and replace them with this interactive REPL. Users really appreciate this. I get way more traffic to my blog site when I use it, so you should definitely use it. For PowerTurtle, we used replum because it gives you more control. It takes a bit more effort to set up, but we like the customization. So that really brings us back to learning Clojure through Logo. The Logo Clojure connection is a steady progression from beginner to advanced. Self-hosted Clojure script makes it easy to get started. Translations make it accessible to the wider world. It's fun, and you're in control. And that's why I believe that Clojure is the very best first language for everyone.
So here's a short list of all the people whose advice, tools, libraries, compilers, and language have made it possible for us to do all the things that we've done. So here are some links to some of the libraries and projects that we've mentioned. And here's our contact information. So we'd love it if you have any comments, suggestions, or contributions. If we have some time, then we're happy to answer some questions. Okay. Okay, great. So let me try to re-summarize. So there was a lot of compliments, and thank you very much. And you said that you're actually using this in the field. I guess to kind of summarize some of the comments, I think it's about how do we transition from something that's stateful, because Logo, you have state, there's a lot of side effects when you're drawing, And how can we transition students towards more data processing and getting them to use seeks and the other functional constructs. And I think that's a good observation and a good comment. And something that we've thought about too. We've heard suggestions that it should be stateless, and that's the true functional way. When I was reading Mindstorms, Papert talks about the syntonicity, or it's syntonic learning, that you have this model that you can kind of relate to as a learner and apply it to the domain that you're trying to work in. So in this sense, the turtle is kind of a reflection for a lot of students of themselves. They are individuals, they move in the environment. So when you're saying, okay, I need to turn right 30 and move forward and then back and then turn left. And so they kind of mimic what they know from their own experience and they apply it to turtle. And so there's this intuitiveness because we moving through the world, it's a stateful process, right? Once we move somewhere, we're there. It's not a stateless thing. So I think there's some value, at least for starting off, but I think the goal then would be to do a very careful transition towards more functional concepts. And I think there are definitely lots of ways that we can explore that.
Yeah, I totally agree with what you're saying, and I just wanted to point out that in Elango's library and in this website, you can actually do that with, there's a call called execute turtle commands, and you can give it a data structure, and it all works.
Yeah,
so I agree.
Yeah, the turtle record, so turtle's defined as a record, and in it, it actually keeps track of the commands that have been given to it. Thank you.
Thank you very much.